Hello everyone, welcome back to my channel Science Learning Point. I am Dr. Oromita and I have a PhD in chemistry. Hope all of you are doing great. Today we are going to begin the first chapter of class 10 science, chemical reactions and equation. So every day we see many changes around us. Ice melts into water, milk turns into curd, food cooks when heated, iron rusts after being exposed to air and moisture, and a candle burns and gives light. Have you ever wondered what is happening during these changes? The answer is chemical reaction. So chemical reactions are taking place everywhere, in our kitchen, in industry, inside our body and even in nature. So in this chapter, we will learn what is a chemical reaction, how to write chemical equation, how to balance chemical equations, different type of chemical reactions, oxidation reaction, reduction reaction, corrosion and rancidity. So don't worry if these terms sound difficult now. By the end of this lesson, you will understand everything step by step with simple examples. So keep your notebook ready, pay close attention and let's begin our exciting journey into chemistry. Let's move to our learning objective. Before we start, let's understand what we are going to learn today. Our first objective is to understand what a chemical reaction is. A chemical reaction is a process in which one or more substances changes into new substances with different properties. Okay, next we will learn about reactants and products. Reactants are the substances we start with and products are the new substances formed after the reaction. Then we will learn how scientists write the reaction using chemical equations instead of long sentences. After that, we will study how to balance a chemical equation. Balancing is important because atoms are never created or destroyed during the reaction. We will also learn different types of chemicals reaction like combination reaction, decomposition reaction, displacement and double displacement reaction. And finally, we will understand oxidation, reduction, corrosion and rancidity, which have many practical applications in our daily lives. By the end of this chapter, you will be able to solve numerical problems, identify reaction types, and answer broad exam questions confidently. Now, let's understand what a chemical reaction is. A chemical reaction is a process in which one or more substances change into one or more new substances. The substances that take part in the reaction are called reactants and the substances formed after the reaction are called products. During a chemical reaction, old chemical bonds break and new chemical bonds are formed. Because of this rearrangement of atoms, completely new substances are produced. Let's look at the simple examples. Hydrogen gas reacts with oxygen gas to form water. The chemical equation is 2H2 plus O2 to 2H2O. Here, hydrogen and oxygen are reactants and water is the product. Notice something interesting. Before the reaction, hydrogen and oxygen have completely different properties. And after the reaction, what happened? They form water, which has completely different property from hydrogen and oxygen. Understand? This shows that chemical reactions create new substances. One very important rule is called the law of conservation of mass. What it states? It states that the matter can neither be created nor be destroyed during the chemical reactions. The total number of atoms before the reaction and after the reaction remain exactly the same. Only their arrangement changes. This is why balancing chemical equation is so important. Can you think of any chemical reaction happening around you? Maybe cooking rice, burning LPG, or digesting food? Yes, yes. All these are example of chemical reactions.
Now let us understand an important question. How do you know that chemical reaction has taken place? When two or more substances react, we may notice some visible changes. These changes give us a clue that a chemical reaction has occurred. There are 5 common signs of a chemical reaction. The first sign is the formation of a gas. Sometimes when two substances react, we can see bubbles coming out. For example, when zinc reacts with dilute hydrochloric acid, hydrogen gas is produced. So, if you see bubbles or gas being released during the reaction, it may be the sign of a chemical reaction. The second sign is the change of color. For example, when an iron nail is present in the copper solution, the blue color of the solution gradually changes to green. Why does this happen? Because new substances are formed during the reaction. So, a change in color can also indicate a chemical reaction. Okay, the third sign is the change in temperature. Some chemical reaction produced heat. These reactions are called exothermic reaction, For example, when certain substances burn, heat is released. On the other hand, some reaction absorb heat from the surrounding. These are called endothermic reaction. So, if you noticed that a reaction becomes hot or cold, a chemical reaction may be taking place. Okay. Next, the fourth sign is the formation of precipitate. Now, what is a precipitate? A precipitate is an insoluble solid that forms when two solutions react. For example, when silver nitrate solution reacts with sodium chloride, a white solid called silver chloride is formed. This white solid settles down in the solution. This solid is called a precipitate. And the fifth sign is the change in physical state. For example, hydrogen gas and oxygen gas can react to form water. Here, reactants are gases while water is a liquid, so the physical state has changed. But remember, a change in physical state alone does not always mean a chemical reaction, okay? So, we should look at the formation of a new substance as well. So, let's quickly remember all 5 things. Gas formation, color change, temperature change, precipitate formation and change in physical state. These observations help us to identify whether a chemical reaction may have occurred. So, whenever you are doing a chemistry experiment, keep your eyes open. Okay. If you see bubbles, a color change, a temperature change, a new solid or the formation of a new substance, stop and think. Could a chemical reaction be taking place? Okay, that's all. I think you can now learn all the chapter. If you have any doubt, please ask me.
Now let's perform a simple laboratory experiment. The aim of this experiment is to observe burning a magnesium ribbon. First, we clean the magnesium ribbon with sandpaper. Why? Because magnesium reacts slowly in oxygen in air and forms a thin layer of magnesium oxide. This layer prevents proper burning. After cleaning, hold the ribbon with tongs. Bring it near to the flame of a Bunsen burner. Immediately, it starts burning with a bright, dazzling white flame. After burning completely, a white powder is left behind. This white powder is called magnesium oxide. The chemical equation is 2Mg plus O2 to 2MgO. Let's understand what happened. Magnesium combined with oxygen from the air. A new substance called magnesium oxide was formed. This means a chemical reaction occurred. So our observations are bright white flame, heat release, white ash formed, new substances produced. Our conclusion is that magnesium understands a combination reaction, and it is also an exothermic reaction because heat and light are released. This experiment is frequently asked in class 10 board exam, okay? So remember the observation, conclusion and balanced equation carefully. In the previous slide, we learned that a chemical reaction forms new substances. But imagine if scientists had to write every reaction in long sentences, it would take a lot of time and space. So, to make chemistry simple and universal, scientists use chemical equation. What is a chemical equation? Chemical equation is the symbolic representation of a chemical reaction using the chemical symbols and formula of the substances. Let's understand the four important types of chemical equation. Number one, word equation. Word equations used only the name of the substances. For example, hydrogen plus oxygen to water. This is the way to understand, but it doesn't show the chemical formula. Number two, symbolic equation. A symbolic equation use chemical symbols and formula. For example, H2 plus O2 to H2O. This gives more scientific information than a word equation. Number three, unbalanced chemical equation. Look carefully at the equation H2 plus O2 to H2O. Let's count the atom. On the left side, there is 2 hydrogen atom and 2 oxygen atom, and on the right side, 2 hydrogen atom and 1 oxygen atom. The oxygen atoms are not equal, so this is an unbalanced chemical equation. Number 4, balanced chemical equation. Now look at this equation, 2H2 plus O2 to 2H2O. Let's count again. In the left side, hydrogen 4 atom and oxygen 2 atom, and right side also hydrogen 4 atom and oxygen 2 atoms. Okay, so now both sides have the same number of atoms. This is called the balanced chemical equation. Okay, so always remember students, a balanced chemical equation obey the law of conservation of mass, which states that atoms are neither created nor destroyed during a chemical reaction. So every chemical equation used in science should be balanced. Now the question is how we balance a chemical equation. Let's learn that step by step. This is the most important topics for class 10 board exam. Balancing a chemical equation. Many students find this topic difficult, but don't worry. Once you understand the steps, it becomes very easy. Okay, let's take the equation H2 plus O2 to H2O. Step 1, write the unbalanced chemical equation. First, write the chemical equation exactly as given. Number 2, count the atoms. Let's count the atoms on both sides. And the reactant side, hydrogen 2, oxygen equals to 2, like this, and product side we should write hydrogen equals to 2 and oxygen equals to 1 in this way. So hydrogen is balanced but oxygen is not balanced. Step 3, balance oxygen first. To make oxygen equal, place 2 before water. Now the equation become, count again, reactants H equals to 2, product and O equals to 2, in product H equals to 4 and O equals to 2. So now oxygen is balanced but hydrogen is not balanced. So what should we do? Step 4. To balance hydrogen, place 2 before hydrogen gas. Now the equation becomes 2H2 plus O2 to 2H2O. Let's count again. See, both side is balanced. You count number of hydrogen and number of oxygen. That is 4 hydrogen in both side and 2 oxygen in both side. Okay. So this is the final balanced equation. Remember these important rules. Never change chemical formula. When you balance a chemical equation, never change the chemical formula and don't write H4 or O4. Only add coefficient in front of the formula. This is a very common board exam question. We have already learned how to write a balanced chemical equations, but did you know a balanced equation can provide much more information? Scientists add symbol to make chemical equation more informative. Let's learn them one by one. Physical state. Every substance has a physical state. We present them using symbols. S means solid, L means liquid, G means gas, and AQ means aqueous solution. Aqueous solution means the substance is dissolved in water. Okay. Heat symbol, triangular. Sometimes heat is supplied during the reaction. We write the symbol of heat above the arrow. Catalyst. A catalyst speed up a reaction without being consumed. We write the name of the catalyst above the arrow. Next is the pressure. Some reaction occur only under high pressure. Pressure is also written above the reaction arrow. And next is temperature. Some reactions require a specific temperature. The required temperature is written above the arrow. So by looking at one chemical equation, scientists can know physical state, heat required, catalyst used, pressure needed, temperature required. This makes chemical equation much more informative. Have you ever felt heat while burning a candle? Or have you ever used an ice pack and felt it become cold? These are called two types of energy changes, exothermic and endothermic reaction. What is exothermic reaction? First, let's understand exothermic reaction. An exothermic reaction is a reaction that releases heat to the surroundings. In simple word, heat goes out of the reaction. For example, burning of wood, LPG, respiration, burning of magnesium ribbon, etc. In these reactions, heat is released, so the surrounding become warmer. In an energy diagram, the products have less energy than the reactant. So we can remember exothermic equal to heat comes out. And now looks at the endothermic reaction. An endothermic reaction is a reaction that absorbs heat from the surroundings. In simple word, heat gives into the reaction. Example include photosynthesis, thermal decomposition of calcium carbonate, melting of ice, and some cooking process. Because heat is taken in, the surroundings may be cooler. in an energy diagram, the products have more energy than the reactants. So remember, endothermic equal to heat goes in. Let's make it super easy. Exothermic means heat is released, surrounding become warmer and energy decreases. Endothermic means heat is absorbed, surrounding may become cooler, energy increases. So the easiest trick to remember is exo equal to exist, heat goes out, endo equals to enter, heat goes in. That's it. Now you know the difference between the exothermic and endothermic reaction. Okay. Now let us learn about the different type of chemical reactions. Our first type is called combination reaction. The name itself gives us a clue. Combination means joining together. So in a combination reaction, two or more substances join together to make only one new substance. Okay, in simple word, many substances combine and become one product. So we can write it like this: A plus B and product is AB. Now let's understand with an easy example. When magnesium reacts with oxygen, it forms magnesium oxide. Here we have two substances, magnesium and oxygen. They join together and form one new substance, magnesium oxide. So this is a combination reaction. Let's take another example. Sodium reacts with chlorine and forms sodium chloride, which is a common salt, you know. Again we have two reactants, sodium and chlorine. They combine and form only one product, sodium chloride. So this is also a combination reaction. You may see combination reactions in some everyday and chemical process too. For example, hydrogen and oxygen combine to form water. Iron can also combine with oxygen and moisture over time to form, you already know in the 9th class what it is called. It is called rust. Now there is one very simple rule to remember. If two or more substances come together and form only one product, it is called a combination reaction. So remember, combination means many become one. That's the easiest way to identify a combination reaction. Okay. In the previous slide, we learned about combination reaction, where two or more substances combine to form one product. Now let's study the opposite type of reaction, called a decomposition reaction. So what is a decomposition reaction? A decomposition reaction is a reaction in which one compound breaks down into two or more simpler substances. So the general form is AB to A plus B. This means one reactant produces two or more products. However, decomposition reactions do not happen on their own. They require energy in the form of heat, electricity or light. Let's study three main types. Number 1, thermal decomposition. In thermal decomposition, heat is supplied. For example, CaCO3 to CaO plus CO2. When limestone is heated, it forms calcium oxide and carbon dioxide gas. This reaction is used in the manufacture of cement. Number 2, electrolytic decomposition. Here, electricity is used. For example, 2H2O to 2H2 plus O2. Electric current breaks water into hydrogen and oxygen gas. This process is called electrolysis of water. Number 3. Photolytic decomposition. In this type, sunlight is required. For example, 2AgCl to 2Ag plus Cl2. Silver chloride decomposes in sunlight to produce silver and chloride gas. This reaction is used in black and white photography. So remember, one reactant, two or more product and energy required for decomposition reaction. So decomposition is simply breaking one compound into simpler substances. Okay. Now let's study displacement reaction. A displacement reaction is a reaction in which a more reactive element displaces a less reactive element from its compound. Its general form is A plus BC to AC plus B. Here A replaces B because A is more reactive. Let's understand with an experiment. We take a blue solution of copper sulfate CuSO4. Now we place a clean zinc strip into the solution. After some time, we observe two changes. The blue solution slowly becomes colorless. A reddish brown layer of copper is deposited on the zinc strip. Why does it happen? Because zinc is more reactive than copper. So zinc replaces copper from copper sulfate. So the reaction is Zn plus CuSO4 to ZnSO4 plus Cu. This is a displacement reaction. Another example is Fe plus CuSO4 to FeSO4 plus Cu. Here iron also displaces copper because iron is more reactive than copper. Okay, so always remember the reactivity series. A more reactive metal can replace a less reactive metal, but a less reactive metal cannot replace a more reactive one. For example, copper cannot replace zinc from zinc sulfate, so no reaction occurs. Displacement reactions are very useful in metal extraction and industrial chemistry. Now let's study another important type of chemical reaction called double displacement reaction. In this reaction, two compounds exchange their ions to form two new compounds. The general equation is AB plus CD to AD plus CB. This means both compounds exchange their positive and negative ions. Let's see with that example. AgNO3 plus NaCl to AgCl plus NaNO3. Take silver nitrate solution. Now add sodium chloride solution. Immediately a white solid appears. This white solid is called silver chloride. The down arrow indicates that silver chloride is an insoluble precipitate. This type of reaction is called a precipitation reaction. So why it is called a precipitation reaction? Because an insoluble solid is formed from two aqueous solution. Clear? Understand? So the main points are two compounds react. Their ions exchange places. Two new compounds are formed. Sometimes an insoluble solid is produced. These reactions are widely used in chemical laboratories for identifying ions. Clear? Next, we are going to learn a very important topic in chemistry, oxidation and reduction. These two processes are very closely connected. Okay, when oxidation and reduction happen together, we call the reaction a redox reaction. Let's understand everything step by step. First, what is oxidation? In the simplest way, oxidation means loss of electrons. It can also mean addition of oxygen or removal of hydrogen. Okay, so remember, oxidation equals to loss of electron. For example, zinc to Zn2 plus 2 electron. Here zinc loss 2 electrons. Therefore, zinc is oxidized. Now let's understand reduction. Reduction means gain of electron. It can also mean removal of oxygen or addition of hydrogen. So remember, reduction equals to gains of electrons. For example, Cu2 plus 2E to Cu. Here copper ion gain 2 electron. Therefore, copper ion are reduced. Oxidizing agent. Now comes an important term, oxidizing agent. An oxidizing agent is a substance that causes another substance to become oxidized. How does it do this? It accepts electron from the other substance. Okay, and because it accepts electron, the oxidizing agent itself gets reduced. So remember, oxidizing agent accept electrons. Okay, now let's understand the reducing agent. A reducing agent is a substance that causes another substance to become reduced. It does this by giving or donating electrons. Because it lost electrons, the reducing agent itself gets oxidized. So remember, reducing agent donate electrons. Now let's put everything together. When oxidation and reductions happen at the same time, we call it a redox reaction. Look at the example in the middle of the slide. Here zinc reacts with copper sulfate. The important part is the transfer of electrons. So in the step 1, zinc loses electron, Zn2 plus, 2 electron loss. Zinc is oxidized. Next step, copper gains electron, Cu2 plus to Cu. Copper ions gain 2 electron, so copper is reduced. And notice something very important, the electron lost by zinc are gained by copper. Okay, the electrons which is lost by zinc are gained by copper. So electrons are transferred from zinc to copper. That's why oxidation and reduction happen together. Now let's identify the agent. Zinc loses electron, therefore zinc is reducing agent. Why? Because zinc gives electron to copper ions. On the other hand, Cu2 plus accept electron. Therefore, Cu2 plus is oxidizing agent. Okay, so remember, Zn is reducing agent, Cu2 plus is oxidizing agent. Now here is the easiest trick to remember the oxidation and reduction. What is the easiest trick? OIL RIG. Okay, OIL oxidation is loss, RIG reduction is gain. Okay, so OIL oxidation means loss, RIG reduction means gain. Let's quickly look at some more examples shown in the slide. Magnesium combines with oxygen, so magnesium undergo oxidation, oxygen gains electron and undergo reduction. And next, iron oxide loses oxygen and become iron, so iron oxide is reduced. At the same time, carbon monoxide gains oxygen and is oxidized. Again, oxidation and reduction happen together. Another example, iodide ion. In potassium iodide, iodide loses electrons and is oxidized. Chlorine gains electron and is reduced. Again, both processes happen together. So let's quickly revise the whole slide. Oxidation equals to loss of electron and reduction equals to gains of electron. Oxidizing agent means accept electron and get reduced, and reducing agent means donate electron and gets oxidized. And when oxidation and reduction happen together, it is called a redox reaction. And easiest trick is OILRIG. Must remember. Okay, student? Electrons are not created or destroyed. They are simply transferred from one substance to another. You must remember this important point. Okay? That's the basic idea of oxidation, reduction and redox reaction. Now let's perform another interesting laboratory experiment. This experiment will help us to understand oxidation and reduction very clearly. In the first part, what we see? At first, take a clean copper strip. Now heat it strongly over a Bunsen burner. After heating, something interesting happens. The reddish brown copper turns black. But why does this happen? Copper reacts with the oxygen present in the air. The black substance formed is called copper oxide. Since oxygen is added to copper, this process is called oxidation. Next part, reduction. Now comes to the next part. We pass hydrogen gas over the hot black copper oxide. After some time, the black color disappears and the reddish brown copper appears again. Here, hydrogen removes oxygen from copper oxide, so copper oxide is reduced. Hydrogen combines with oxygen and forms water. Therefore, hydrogen acts as a reducing agent. What do we observe here? During oxidation, brown copper turns to black copper oxide, and during reduction, black copper oxide turns to brown copper. So we can clearly see the changes in our own eye. This experiment shows us both oxidation and reduction. Copper gains oxygen, so it is oxidized, and copper oxide loss oxygen, so it is reduced. And remember, oxidation and reduction occur together. These redox reactions are very important in metallurgy, industry, batteries and respiration. Now let's learn about corrosion. Have you ever seen an old iron gate with a reddish brown layer on it? Or an old bicycle that starts to rust after being exposed to rain? That reddish brown layer is called the rust, and the process that causes it is called corrosion. So what exactly is corrosion? Corrosion is the slow damage of a metal because it reacts with substances in its surroundings, such as air, moisture or chemicals. The metal slowly changes into the new substance. As a result, the metal can become weak and damaged. The most common example of corrosion is rusting of iron. When iron is exposed to oxygen and moisture, it slowly forms rust. Rust is a reddish brown substances that appear on the surface of the iron. If rusting continues for a long time, the iron can become weak. Corrosion can cause many problems. For example, bridges can become weak, railway tracks can become damaged, cars and bicycles can rust, water pipes can develop holes, and machines and ships may need regular maintenance and repair. So corrosion can be serious problem. How can we prevent corrosion? Luckily, there are several ways to protect metal. First, painting. Paint causes a protective layer and stops air and moisture from reaching the metal. Secondly, oiling or greasing. Oil or grease forms a protective coating on the surface. Third, galvanization. What is galvanization? In this method, iron is coated with zinc to protect it from rusting. Fourth is electroplating. Electroplating is a thin layer of another metal such as chromium or nickel, which is placed on the surface of the iron. Fifth is alloying. For example, iron can be mixed with chromium and nickel to make stainless steel, which is much more resistant to corrosion. So let's remember, corrosion means slow damage of a metal due to its surroundings. Rusting is the common example of corrosion, and we can prevent corrosion by using paint, oil, galvanization, electroplating and alloying. So corrosion may be slow, but its effects can be serious. That's why protecting metals is very important in our daily life and industries. Now let's discuss a topic that we experience in our daily lives. Rancidity. Have you ever opened a packet of chips or biscuits and noticed a bad smell or strange taste? It happens because of rancidity. So what is rancidity? Rancidity is the oxidation of fats and oils in the food. When food containing fats or oils is exposed to oxygen in the air for a long time, the fats slowly react with oxygen. As a result, the food develops an unpleasant smell and taste. This process is called rancidity. What causes rancidity? There are several things can make rancidity happen faster. What is the things? For example, oxygen, heat, sunlight, moisture and long storage time. These conditions speed up the oxidation of fats and oil. Here is some example. We can see rancidity in many foods. For example, chips can lose their fresh taste. Butter can develop a bad smell. Cooking oil can become spoiled, and nuts can lose their freshness. How can we prevent from rancidity? Now, how can we stop or slow down rancidity? First, we can store food in airtight containers. This reduces contact with oxygen. Second, refrigeration can slow down the chemical reactions. Third, vacuum packing removes most of the air from the food packet. You may have noticed that many packets of chips are filled with nitrogen gas. So nitrogen does not easily react with fat and oils. So it helps prevent oxidation. We can also use antioxidants which slow down oxidation and help food stay fresh for longer. So let's remember, rancidity equals to oxidation of fats and oil in food. It can cause an unpleasant smell and taste, and we can slow it down by reducing exposure to oxygen, heat and light. One interesting point to remember is corrosion, damage metals while rancidity spoil food. Both involve oxidation, but they affect different material. Now let's understand something very interesting. Chemical reactions are not limited to the laboratories. They happen all around us every day. Let's look at some common example. Number 1, respiration. First, let's talk about respiration. Inside our body, glucose reacts with oxygen and release energy. We use this energy to walk, run, study, play and do our daily activities. So, respiration is also a chemical reaction. Next is digestion. The food we eat is made up of complex substances. Our body breaks them down into simpler substances through chemical reactions. These nutrients are then absorbed by our body and used for energy, growth and repair. Next, cooking. Even cooking involves chemical reaction, you know. When we heat rice, vegetables or egg, chemical changes take place. Their taste, their color, smell and texture can change. And many of these changes cannot easily be reversed. Now let's talk about plants. Plants prepare their own food through a process called photosynthesis. They use carbon dioxide, water and sunlight to make food. You already know the reaction. The glucose produced is used by the plant as food and oxygen is released. So photosynthesis is extremely important for life on earth. Number 5, another common example reaction is combustion or burning. When fuel such as LPG, petrol, diesel or wood burns, they react with oxygen. They release heat and light. We use this energy for cooking, transportation and generating electricity. Now look at rusting. When iron reacts with oxygen and moisture, it slowly forms rust. Rusting is an unwanted chemical reaction because it damages iron objects. We can prevent rusting by painting, galvanizing or coating the metal. Next, have you ever seen a freshly whitewashed wall? Whitewashing also involves chemical reaction. First, quicklime reacts with water to form slaked lime. Then, when it is applied to the wall, it reacts with carbon dioxide in the air. These form hard white coating on the wall. Finally, let's talk about food preservation. We use methods such as refrigeration, vacuum packing and antioxidants to slow down chemical changes in food. This helps food stay fresh for a long time. So, what have you learned? Chemical reactions are happening everywhere around us. From breathing and digestion to cooking, photosynthesis, burning, rusting and food preservation. Chemistry is a part of our everyday life. So remember, chemistry is not only inside a laboratory. Chemistry is all around us. Okay, so congratulations We have completed the chapter. Now let's quickly revise the whole chapter. We have learned many important things about chemical reactions. First, what is a chemical reaction? A chemical reaction is a process in which one or more substances change into new substances. Now let's remember the different type of chemical reaction. Number 1, combination reaction, where two or more substances combine to form one product. Remember, may become one. Number 2, decomposition reaction. Here one compound break down into two or more simpler substances. Remember, one becomes many. Number 3, displacement reaction. Here a more reactive element replaces a less reactive element from its compound. For example, zinc replaces copper for copper sulfate. Number 4, double displacement reaction. Here two compounds exchange their ions and form two new compounds. Next, we learn about oxidation and reduction. Oxidation can mean addition of oxygen or loss of electron. Reduction can mean removal of oxygen or gain of electrons. When oxidation and reductions happen together, we call it a redox reaction. We also learn about corrosion. Corrosion is a slow destruction of metal due to air, moisture or chemicals. A common example of rusting is iron. How can we prevent corrosion? We can use methods such as painting, oiling, galvanization, alloying and electroplating. Finally, we learned that a chemical reaction are very useful in our daily lives. They are involved in respiration, digestion, cooking, photosynthesis, combustion, rusting, whitewashing and food preservation. So let's remember the main idea. Chemical reactions are happening all around us. They are important in our body, home, industry and environment. So the final message: think, learn, understand and apply. If you understand the reaction, you can easily identify what is happening and why it is happening. That's it. Our chapter is now completely revised. Well, excellent. Now it's time to check how much you have learned. Let's answer these 5 questions. You think and answer in comments. Great job. If you answered most of the question correctly, you have understood this chapter very well. Okay. Thank you for learning with Science Learning Point. And if you enjoy this lesson, please like, share and subscribe to support the channel and never miss our upcoming science lessons. See you in the next chapter. Happy learning.